This is Mr. Anderson for Kellogg Community College. For our final video talking about the applications of quadratic equations, we are going to be isolating some variables. Note that in this section we will not be following some of the rules of radicals that we followed in the previous chapter. For example, we might leave some square roots in the denominator. We also will be ignoring, when we take the square root, the positive and negative of a variable, because in all of these story problems we're probably not going to deal with negative time or negative distance or negative values from that case. So whenever we take the square root, we'll only be looking at the positive value of that and not the positive and negative. So in this, for 8 through the rest, we are going to take a look at just solving for the variable indicated. Now, at the start of each problem, I'm going to isolate my variable, which is going to be s squared. I want the s to be all alone, and I'm going to use the symmetric property to put my s on the left-hand side. I'm just changing the order from left to right, and then what I'm going to do is just start to isolate my variable. I'm going to divide both sides by 6 using an inverse operation here. S squared is equal to a over 6. And then what I'm going to do is do the inverse operation of squaring, which is square root. So if I square root both sides here and here, what that is going to give me is s is equal to, now again, I'm not using the positive or negative. I'll just take a look at the positive value of a over 6. Now we're not going to rationalize the denominator by multiplying the top and bottom by 6. If I did, that would give me s is equal to the square root of 6a over 6, but this is going to be completely acceptable. Let's move to the second part here, and again, I'm going to start off like I'm taking a look at problem number 9 here, and I see in problem number 9 that the k's are what I want to get by themselves, so using the symmetric property, I'm going to switch the problem around so my k is indeed on my left and my n is on my right. Now I'm going to use my cross multiplication or rationalizing or getting, clearing the denominator, so I'm going to multiply both sides by 2 over 1. These simplify out then, and that's going to leave me with k squared minus 3k is equal to 2n. Now since I'm trying to get the k by itself and I have more than one k, what I'm going to do is move this 2n to the left hand side. So k squared minus 3k minus 2n is equal to 0. Now this looks like a quadratic expression, except I'm going to, instead of my a, b, and c being all whole numbers, check out this. My a is 1 because there's nothing in front of the k squared. My b is negative 3 because there's nothing in front of my k. And my c is negative 2n, which is going to make my quadratic formula look a little funky here. This is going to be 3 plus, remember we're not checking out the plus or minus, we're just taking out the plus part. 3 plus the square root of negative 3 squared minus 4 times a times c, negative 2n here, and we're going to be simplifying this all over 2a, which is 2 times 1. So let's simplify this as much as we can. So this is 3 plus, again we're not caring about the minus since these are story problems, the square root of 9 minus negative 4 times 1 times negative 2 is positive 8n all over 2. And this is going to be my answer for the values of k. Because I don't have any way to simplify this, I can't just remove a square root of 9 since it's part of a binomial, so we're finished with the problem. Looking at problem 10, I'm trying to get my s isolated, so using my symmetric property, I'm going to have my k, my q sub 1, q sub 2 is equal to n divided by s squared. Now using my clearing of the denominator, I'm going to multiply both sides by s squared. What this will do is these will simplify on the left hand side, and I'm left with is k q sub 1 q sub 2 is equal to n s squared. Dividing both sides by n to get the s squared by itself, what we're going to have is k q sub 1 q sub 2 divided by n is equal to s squared. To get the s by itself, we're going to take the square root of both sides. And since this is a story problem, we don't care that this is going to be plus we don't have to worry about plus or minus. We just have to have the square root of k, q sub 1, q sub 2 divided by n. And there it is. There is my final problem here. Now we're not going to clear out the n in the denominator. To multiply top and bottom by square root of n. If you were to do that, you'd have the square root of k q q n divided under the square root divided by just n by itself. But that is going to be acceptable for our bookwork today. Okay, moving on to problem number 11 and 12. Okay, in problem number 11, we're trying to get h by itself, so let's move this problem around here. Let's do a little symmetric property. Even though that didn't really benefit us in the last problem here, I still do enjoy getting my variable over to the left-hand side that I want to isolate. Divide both sides by 3.5, that's the inverse operation of multiplication. So the square root of h is equal to v over 3.5. Now to get this h by itself here, sorry it looked like an n for a moment, we're going to square both sides. So this leaves me with h is equal to v squared over the square of 3.5, which is 12.25. And that is going to be the answer there. Now this one's interesting. This is a little three-dimensional action like Pythagorean theorem in the 3-dimension. We're going to take a look at the b, trying to get this b isolated by itself. So we're going to move that a squared and the c squared to the other side, kind of ignoring the rules of the order there. You'll see that the book doesn't follow the rules of descending power by alphabetical order. So this is going to go d squared minus a squared minus c squared. And then we'll take the square root of both sides, so b is equal to the square root, only the positive root now, of d squared minus a squared minus c squared. And there's your answer there for problem 12. Okay, moving on to problem 13. I think we can do 13, 14, and 15 in the same screen here. Okay, so moving on here, we're going to take a look at solving for the letter r. And again, because I enjoy my symmetric property, I'm going to put my pi r squared plus pi rs over here on the left-hand side and flip my problem around. Now I'm going to move my a over here since I want to set this equal to 0, and I kind of figured that out because I have an r squared and I have a pi s times r. Notice that I'm putting my r's at the end of these terms, minus a equals 0. Now I can use the quadratic formula. So the pi is my a, the pi s is my b, and then this minus a is going to be my c. So the a is pi, the b is pi s, and the c is negative a. So here we go. We're going to now take a look at negative b, so negative pi s plus, not plus or minus, the square root of pi s squared minus 4 times a, which is pi, times c, which is negative a. It's going to be a nice answer, right? And this is multiplied by 2 times a, or 2 pi. So to simplify the numerator here, negative pi s plus the square root of pi squared s squared plus 4 pi a divided by 2 pi. Whew! Yeah, that's it. That's solving for the letter r. That's r equals all of that. It's pretty crazy, isn't it? All right. This next problem is a little weird. We're going to solve for r. So again, using my symmetric property, I'm going to flip-flop my problem. A sub 0, 1 minus r squared is equal to a. We're going to divide both sides by a sub 0, a sub 0. So 1 minus r quantity squared, or sorry, no, 1 minus r squared is equal to a over a sub 0. Now what I'm going to do is I'm going to subtract this, let's see here, I'm going to subtract this 1 from both sides. So what that is going to give me here, it's going to give me negative 1 plus a divided by a sub o. So this is my r squared is still over here. Whoops, forgot my negative r. So what I'm going to do is now I'm going to divide everything by negative 1. So my r squared is equal to 1 minus the a divided by a sub 0. And then I'm going to take the square root of both sides here. And so r is equal to the positive square root of 1 minus a over a sub 0. There we go. Well, it looks like I'll need a little bit more room from my 15 here, so let's go draw this down a little bit. Okay, so we're solving for L, and again, since I love my symmetric property, I'm going to rewrite this so the L is on the other side, even though that may or may not help in this situation. So I think maybe the first thing I'll do, instead of moving things around, I'm going to try to get rid of this square root here that's blocking my L there. So I'm going to square both sides here. Now if I square both sides, I get w squared is equal to 1 over LC. Then it just becomes an object, and this is kind of a cool trick that some people know and some people don't know. When you have two fractions equal to each other, it is a process to, you can invert both of these. So I've got 1 over w squared is equal to LC over 1. Now what this allows me to do too is allows me to then divide both sides by c, and if I divide both sides by c to get the c's to simplify out, I'm left with L is equal to 1 over c w squared. Alright, well thank you for watching.